Hello, everyone. My name is Shu. Today, I'm going to introduce our latest product, Lisk SDK 5.0 and Lisk Core 3.0. With Lisk SDK 5.0, we have completed all the implementation of the lips that was proposed, but also we have implemented With the 5.0, we are confident that our fundamental architecture is complete, and we are ready to implement a lot of blockchain features and blockchain application using SDK and extending SDK, including the interoperability that will be introduced by Alexander later. Lisk 5.0 includes on-chain architecture, off-chain architecture, and communication architecture. And using that SDK, we have also improved our Lisk Core 3.0, which is now a command line interface, and it has a new procedure for installation, configuration, and startup. Lastly, I'll explain the current status of this release and the next steps. Let's move on to Lisk SDK 5.0. So what is Lisk SDK 5.0? So Lisk SDK is a set of libraries to create the blockchain application and surrounding tools. Within Lisk SDK, we have three main products: Lisk Commander, Lisk Framework, and Lisk Elements. Lisk Commander is the entry point for a developer into the blockchain. This feature will be implemented in coming minor releases. Lisk Framework is the package to create the blockchain application instance. Internally, it uses Lisk Elements, which is a separately installable packages. And each packages includes specific blockchain logics. And some of the packages can be used to build UI products. And the main architecture is built in Lisk Framework. It is flexible by on-chain architecture. It's integrable by off-chain architecture, and it's open through communication architecture. Let's dive in a little bit more. Lisk Framework exposes application, which is umbrella for all the logics. And on one side, we have off-chain logic, which is managed by controller and implemented using plugins. On the other side, we have on-chain logic, which is managed by node and implemented using modules. But what do I mean by on-chain and off-chain? On-chain is a part of the blockchain protocol, and it introduces state mutation through block or transactions. And all the logics are verifiable by everyone by synchronizing to the blockchain. And it is handled in what we call module. On the other hand, off-chain logic is not part of the blockchain protocol. But oftentimes, to build a real web service or any other systems that uses blockchain technology, it's not really enough to only have an on-chain logic. That's why we also created this off-chain. And this is handled in what we call plugins. Let's dive into the on-chain architecture. On-chain architecture, as I said, it's handled in module. And each module, it needs to define the data structure using the account schema. And also, it needs to add the logic using lifecycle hooks. And in one module, it can have multiple transaction assets. And each asset also needs the structure to be defined, and also the execution logic. And oftentimes, the module contains important information or logic that can be used externally. That's why we also created these reducers, action, and events to communicate to outside. I'll explain piece by piece in coming slides. So the module needs to mutate the states of the blockchain. And to do that, we have prepared two states. One, account state, and another one, chain state. Account state is something that corresponds to each Lisk address. But sometimes it's not enough to just to store data into the account. That's why we also created the chain state, which stores the global information on the blockchain. But having only the data is not enough. We need to add the logic to it. So that's why we also added this module hooks. We currently have 5 hooks: before block apply, before transaction apply, apply, after transaction apply, and after block apply. When a node receives a block, after it verifies all the basic properties, it goes through each of these hooks. And when everything is successful, it will store all the mutated states and the blocks. Module has multiple assets inside. And this is basically equivalent to the custom transaction we had in the previous versions. Each asset contains a data schema and also execution logics. Reducers are a function to be exposed to the other modules. For example, our default module, token, manages the balance. But other module also needs to call or mutate the balance. That's why we need this reducer to expose some of the functionality from the modules. But module also contains the information that can be used in external systems. To expose the information to the external system, we have added this action and events. Those are information that can be used in off-chain, in plugins, or any other external systems. So in summary, modules are responsible for adding blockchain protocol logic. All logic must be deterministic. Schema are defined for storing account state. Hooks apply logic during the block lifecycle. Reducer exposes interfaces to the other modules. And action and events provides information, plugins, or external systems. We have now 4 of those default modules. Token modules, as I mentioned a little bit earlier, it manages the balance. Sequence module, it manages the nonce, which prevents the double spending. Keys module manages the signatures, especially our multi-signature scheme. DPoS module manages delegated proof of stake and chooses the block producers. But what can we build using this module? Module can define block-level logic. For example, we can implement something that executes every 100 blocks. We can implement something that invalidates a block by block header or payload. We can also include a logic which is executed per transactions. With all this feature, we can also implement something like new consensus algorithm, like proof of authority, proof of stake, or any other various DPoS implementation. But not only that, we can implement any deterministic and state changes logic, which can be an FD implementation, which Manu will explain later, or smart contract platform, or any other things. Let's talk about off-chain architecture. Off-chain architecture are some logic to improve the blockchain protocol. But because it's not blockchain protocol, it can be run in different process. So during the development, we might want to implement using the same process, but in the production, we should run in the child process. And also, plugin might contain the information that we want to use in external systems. That's why we also added action and events. So action and events are basically exactly same as the module. It is there to provide the information to external systems or external module plugins. So in summary, plugin is the way to provide off-chain logic and can be run in different processes. It is optional to run with a blockchain application, and it can expose action and events for internal data, but also it can access all the action and events registered into the module or plugin. We have now also for plugins, HTTP API plugins, which exposes basic blockchain information through REST API format, Forger plugin, which tracks the forging activity, report misbehavior plugin, which observes the network and automatically detects the misbehavior and sends the transaction, monitor plugin, which we use during the QA, which tracks the node activities and exposes in Prometheus format. So what can we build using plugins? As I mentioned earlier, we have default module monitoring, but also we can observe the network or blockchain and aggregate the data and exposes calculated data to the external system to be more usable. We can do automation, something like what we do in the report misbehavior plugin. But what's more interesting is that we can build something like Oracle. The plugin can observe other web services or systems and calculate the new data, and then send those data to the blockchain through transaction. The last main thing is communication architecture. Throughout the presentation, I mentioned several times about action and events. Action and events are at the end registered to the application and exposes through IPC Unix socket or WebSocket. Because those two protocols are common, of course JavaScript, but all the other languages that supports those protocols can access those information. And all communication is written through in JSON RPC, so it's easy to integrate. For JavaScript user, we have updated API client. Our new API client communicates using IPC or WebSocket, but also on top of that, because our block, transaction, and accounts communicates with the binary encoded data, internally in API client, we decode those data and provide the JavaScript object to user. And also, all the actions and events which is registered to the application from modules or from plugins are all accessible through API client. So that was it for Lisk SDK. Now let's talk about Lisk Core 3.0. What is Lisk Core? Lisk Core is a blockchain application created using Lisk SDK. So in a way that Lisk Core is the first user of our Lisk SDK. It's a blockchain application that powers our Lisk mainnet and testnet and uses all the default modules that we provide in Lisk SDK, so which runs DPoS algorithm, and also internally in Lisk SDK, we implement the BFD consensus for block finality. So that is also same for Lisk Core. And it's fully written in TypeScript, and now with this version, it's also a command line interface. Installation is similar to what we had before. Binary table, Docker image, and source code. But from this version, we also provide npm installation, which means we can do something like npm install global Lisk Core. Because it's the CLI, it's really easy to start your own node. You can download Lisk Core and simply type Lisk Core start. And configuration can be done through the config file, or we provide a lot of flags to override existing configuration. So this is an example. Once we do npm install, Lisk Core command will show you all the commands that you can use. When we migrate this version to our mainnet, the minimum configuration or minimum command that you need to do is Lisk Core start, which will start your own mainnet node. In the meantime, Or if you want to connect to our testing network, you can do something like Lisk Core start, -- network testnet. And also, if you want to expose a WebSocket communication, you can specify API WebSocket. And there is a lot more flags for the start command, and it will be written in the help command or in our documentation. But start is not only the command that we have in core. The core can communicate to the local running node and manage the running node. For example, we have a blockchain and forging database export and import. We can get the account. We can also create the account. We can get the transaction, create the transaction, sign, and send to your running node. So that was it for Lisk Core. And now I'm going to explain a little bit our current status of our release. So right now, we are doing security audit with our auditor least authority. It is scheduled to be done next month. At the same time, we are preparing our documentation for Lisk SDK 5.0 and Lisk Core 3.0. And for development, we're adding a lot more tools for Lisk SDK to build UI tools. Earlier this year, we have released BetaNet version 3, which uses Lisk SDK 3.0. This month, we released BetaNet version 4, which uses Lisk SDK 4.0. And earlier next month, we will release BetaNet version 5 with our latest SDK. Depending on the test result coming from security audit and the BetaNet, we will plan our testnet and mainnet releases. That was it. Thank you very much.
Thank you, Shu. Awesome. There were some announcements packed in there. So let me repeat. Our security auditor's name is Least Authority, and they will be done with their security audit still this year in December. Further, the next BetaNet version 5 will also still launch this year in December. So it's true to say that Christmas came early this year.